Example 1. Find the values of the 6 trigonometric functions for a 45-degree angle in a 45-45-90 triangle with legs that are 4 centimeters. So I've drawn it already. So it's isosceles with 4, 4. We got all that, I think. So we want to find all 6 of these things. So we'll start with the original ones. So sine of 45 degrees is going to be opposite over hypotenuse, right? So katoa. So opposite over hypotenuse. Well, the first thing I guess I need to do is I need to put 4 root 2 there. We know that's 4 root 2 because it's one of our special triangles and we know the pattern. So it's going to be opposite over hypotenuse. So we'll choose this one, although it doesn't matter. So we get 4 over 4 root 2, which is just 1 over root 2, which we simplify by multiplying root 2 on the top and bottom. So we're actually going to get root 2 over 2. Okay. Next, we have cosine of 45 degrees, right? And so that's going to be adjacent over hypotenuse, but since it's isosceles, we get the same thing. So I'm going to skip those next steps and just do root 2 over 2. All right, and then we do tangent of 45 degrees, and this is just going to be opposite over adjacent, so 4 over 4 or 1. That's nice. All right, now for the new ones. All right, so for the reciprocal of sine, we have cosecant, right? CSC of 45 degrees. So the reciprocal of sine is going to be hypotenuse over adjacent, or you can look at the answer of sine and just flip it over, and that's what I'm going to do. So it's going to be 2 over root 2. We have to simplify this, so we get we multiply the top and the bottom by root 2, and we get 2 root 2 over 2, or just root 2. Right? And that makes sense because before we did this, we had this answer, right? So before we had to change the way it looks to get the radical out of the denominator, we did have 1 over root 2. So the reciprocal of that would be just root 2. All right, next we have the secant, which is SEC of 45 degrees, and that's the opposite, right? That's the opposite of cosine of 45 degrees. Well, opposite's kind of the wrong word. Reciprocal of cosine. So again, we just flip the cosine, but we already did that when we flipped sine because this is an isosceles triangle. So we already know this answer is just root 2. All right, and then finally we have cotangent of 45 degrees, and that's going to be 1 over tangent of 45 degrees. Tangent was just 1. Tangent was just 1. So flipping that over, you just get 1 again. All right. Next, we'll go to number 2. And there we have, so FGH, tan of F is 5 over 12. Find this other stuff. So the first thing we got to do here is figure out where we're going to put the F, the G, and the H, and the 5 and the 12. So I drew a triangle. I'm going to put the right angle here. I'm going to add the 5 and the 12 first, right? And then I know that tan of F is equal to 5 over 12, and I know that tangent is TOA, right? Opposite over adjacent. So that means that 5 should be the opposite side from f. So now I know that f is going to be right there. And also G is a right angle, so H would be that last one right there. Okay. Now let's go ahead and solve the problem. So we have cotangent of f, right? So cotangent of f, well, we didn't really need to do anything to get that. That's just 1 over tangent of f, right? 1 over tangent of f, which is just going to be 12 over 5. Done, right? But if we want sine of f, we do need to go ahead and get that last side. So first I'll just go ahead and write it out. So sine of f, and that's going to be right here, so opposite over hypotenuse, right? So 5 over something. To figure out that something, I'm just going to do 5 squared plus 12 squared is equal to hf squared. And open this up. 5, clear the stuff we have there. 5 squared plus 12 squared. Hit enter, and then take the square root of that number, 169, and we get 13. So this is 13. So HF is equal to 13. Although I guess I should go ahead and write that down for everyone. So 5 squared plus 12 squared was 169, right? Yeah. Is equal to HF squared, square root, 13 is equal to HF. And now we can put that 13 in there. All right, pretty good there. For number 3, we want to find the values of all 6 trigonometric functions for angle T in this triangle if angle R is 36. All I would do is just do 90 minus 36, which equals 54 degrees, and put that in for T, so that's 54 degrees. And then I would use a calculator. Essentially, I don't need to solve for S or little t, side S or little t. So I just grab a calculator and do sine of 54 degrees, cosine of 54 degrees, tangent of 54 degrees. We want to do cosecant of 54 degrees, secant of 54 degrees, and cotangent of 54 degrees. And yeah, I will go ahead and do that with the calculator, but certainly you can do it as well. As you see, I already did this problem earlier as well. So there's cosine and tangent of 54 degrees. All right, so I have those three. So 0.81, 0.59, and 1.38 after rounding. All right, for the other ones, instead of using these rounded numbers, I would actually type into the calculator 1 over sine of 54 degrees to get that, 1 over secant of 54 degrees, and not secant, and 1 over cosine of 54 degrees, and 1 over tangent of 54 degrees. So I'll just go ahead and type those into the calculator. So 1 over sine 54, right? and that gets me 1.24, and you could double check that if you want. If you do 1 divided by 0.81, it should get you about the same number, and you see that it does. Pretty close, but that one is not quite right since we rounded. Right, so that was 1 divided by sine of 54, then 1 divided by cosine of 54, and that's 1.7, and 1 divided by tangent of 54 for cotangent, and that's 0.73. All right, so that's just an introduction on how to use those reciprocal functions, cosecant, secant, and cotangent, with some examples. And that is the end of 8-4. Thank you.